Hello everyone, welcome to our video and we are presenting Monte Carlo simulation, unraveling randomness predicting the unpredictable. In this video we are going to talk about introduction to Monte Carlo simulation, key features, working mechanism, real-world application in stock market forecasting, pros and cons of Monte Carlo simulation, conclusion and summary. Now imagine you are in a casino. The glitz, the glamour, the element of chance is always there. What if you wanted to know your actual chances of winning in a casino game like roulette? It's not just about luck, but also a touch of science. Suppose you want to know your real chances of winning if you bet on red. How would you figure it out? Instead of relying on complicated formulas, what if we just spin the wheel thousands of times and see how often you win? That's Monte Carlo simulation. It uses randomness and repetition to find probabilities. So, what actually is Monte Carlo simulation? Let's dive deeper. Monte Carlo simulation is problem-solving technique based on repeated random sampling. It helps us make predictions in situations where direct calculation is too complex. The more simulation we run, the more accurate our results become. So let's talk about its key features. It uses randomness and probability distributions widely applied in statistics and probability. Finally, it estimates numerical results by repeated random sampling. So you must be wondering, how does Monte Carlo simulation work? Suppose we are playing a dice game and we want to estimate the probability of rolling 10 dice and getting a sum of 40 or more. To estimate that, we will use Monte Carlo simulation. The rule is simple. In each 10 dice rolling, if we get sum of 40 or more, we win. But instead of rolling dice again and again manually, we'll let the computer do it for us. And if we roll 10 dice, the total sum can vary from 10 to 20. But the real challenge is estimating how often we'll get 40 or more. Now let's run the simulation 1 lakh times. Each time the computer rolls 10 dice, sums them up and check if the total is 40 or more. By running this simulation, we get an estimated probability of winning the game. Here's the output. The probability of rolling 40 or more is about 20%. Now let's visualize this with a histogram. The histogram shows how often different sums occur. The most common results are around 35, while 40 plus happens less frequently. Monte Carlo simulation allows us to estimate probabilities in complex situations where direct calculation is difficult. Now the final takeaway is Monte Carlo simulation helps estimate probabilities that are hard to calculate manually. The probability of rolling 10 dice and getting 40 plus is 20%. The histogram visually shows how often different sum occurs. Now, moving forward to real-world application of Monte Carlo simulation. The first one is finance and investment. Monte Carlo methods aid in portfolio optimization, asset pricing, and investment strategy evaluation by simulating various financial conditions and their impacts. This provides a more comprehensive view of potential outcomes beyond static analysis and stock market analysis. Monte Carlo simulation is used to predict stock price movements and market trends by simulating thousands of possible future scenarios based on historical data and volatility. This allows investors to better understand the potential range of outcomes for their investment. Risk management. It helps assess potential losses in investments by modeling different risk scenarios such as value at risk (VAR) to ensure informed financial decisions. Understanding potential downside risk is crucial in a volatile market. Engineering and manufacturing. Monte Carlo simulation is widely used to improve product reliability, optimize production processes, and manage uncertainties in manufacturing by modeling different operational scenarios. Reliability testing. Monte Carlo simulation helps predict the lifespan and failure rates of machines and components by simulating various stress conditions and user scenarios. This proactive approach to testing saves time and resources in long run. Quality control. It is used to assess defect rates in manufacturing by modeling variations in raw materials, production processes, and even environmental factors. By understanding the interplay of these variables, the simulation helps identify potential weaknesses and the quality that customer can rely on. Logistic and supply chain. Monte Carlo simulation helps optimize supply chain operation by predicting demand fluctuations, improving inventory management, and enhancing warehouse efficiency to reduce cost and delays. The goal is to make the supply chain smoother and more responsive. Inventory management. It is used to forecast demand, optimize stock levels, and minimize shortages or overstock situations by simulating different supply and demand scenarios while helping to save resources. Warehouse optimization. It helps improve storage space utilization, streamline picking and packing processes, and significantly enhance overall warehouse efficiency. By modeling and analyzing various operational strategies, you can identify optimal layouts and resource allocation for a smoother and more cost-effective logistic process.
Now, let's discuss about real-world applications in finance. Monte Carlo simulation is widely used in finance to access risks, predict stock prices, and model market behavior. Using this, analysts can run thousands of simulations to estimate future stock prices and potential risks. Now, let's discuss briefly about why Monte Carlo simulation is used in stock market forecasting. It helps to predict future stock prices by allowing traders and financial analysts to prepare for different market conditions and make informed investment decisions. Let's take a look after visual representation of stock price simulation. The graph here represents different possible stock price movements based on thousands of Monte Carlo trials. Each line represents a possible path the stock price could take, showing the range of possible outcomes. Investors can use this information to set realistic expectations and create strategies. In risk assessment, Monte Carlo simulation helps by analyzing different scenarios such as the probability of a stock losing value within a certain period. Now, let's take a look after visual representation of a risk assessment. This visualization shows how Monte Carlo simulation helps in evaluating financial risks. By running multiple simulations, analysts can determine worst case, best case, and average case scenarios. Businesses and investors use these sites to protect themselves from extreme losses. In market volatility analysis, it models the impact of sudden market fluctuations. It allows financial planners to prepare for uncertain market conditions and make decisions based on statistical probabilities. Let's take a look after visual representation of risk assessment. This visualization highlights the role of Monte Carlo simulation in evaluating stock price risks. By simulating different price trends and market conditions, investors can better prepare for both risks and opportunities. Understanding these risks is essential for developing long-term investment strategies. What might be the pros and cons of Monte Carlo simulations? Monte Carlo simulation is great for handling uncertainty in complex problems. Instead of a fixed answer, it provides a range of probabilities, helping businesses make informed decisions. It is widely used in finance, engineering, and AI. It handles the complex problem into uncertainty. Many real-world problems involve uncertainty. It allows us to model different scenarios and find the best possible outcomes, making it a valuable tool for industries dealing with unpredictable conditions. It provides a range of probabilities. Unlike traditional methods that give a single outcome, it runs multiple simulations to estimate different probabilities. This helps businesses and analysts understand possible risks and rewards before making important decisions. It works well in finance, engineering, and AI. This method is widely used across industries. In finance, it predicts stock market trends. In engineering, it estimates system reliability. And in AI, it helps to train models under uncertain conditions. For example, in engineering, it helps to predict the lifespan of a machine part based on different stress conditions. Despite its benefits, Monte Carlo simulation has some drawbacks. It requires high computational power, meaning more simulations take longer to progress. Additionally, errors can occur if not enough simulations are run, making results unreliable. It requires high computational power. Monte Carlo simulation involves running thousands or even millions of simulations. This requires significant computing resources, especially for complex problems, making it slower and more expensive. Since Monte Carlo relies on randomness, few simulations may lead to inaccurate results. The accuracy improves as the number of trials increases, but too few can create misleading conclusions. The accuracy of Monte Carlo simulation depends on how many times it runs. If too few simulations are performed, the result might not reflect real-world probabilities, leading to unreliable predictions. For example, in weather forecasting, using only a small number of simulations might lead to inaccurate predictions of extreme weather events. In a final note, Monte Carlo simulation is a powerful tool for predicting probabilities and solving complex problems in finance, engineering, AI, and logistics. It helps decision makers by providing a range of possible outcomes rather than a single predictions. It requires careful implementation to ensure accuracy and meaningful results. To wrap up, we have explored how Monte Carlo simulation is used to solve complex problems by modeling uncertainty and running multiple simulations. It is widely applied in finance for risk analysis, in engineering for system reliability, and in logistics for inventory and warehouse optimization. Overall, Monte Carlo simulation is a powerful decision-making tool, helping industries make smarter data-driven choices in uncertain environments.